Hello, you absolute legends. This equation up here is fascinating in that it relates that the Gibbs energy is related to capital K, the equilibrium constant, through a function of its natural log with respect to R and T right here. We need to just do some algebra just to kind of show how to solve for each of these terms here. So G, if you're asking to solve for G, let's lay out what these terms are here. R is the gas constant. You know this constant. This constant is totally findable on Wikipedia. You just have to match up the units that come with it right here. So R joules per mole degree Kelvin. You always kind of know that number there, or at least have it handy. The temperature in this case, make sure the temperature is always going to be in Kelvin. Most often we do things at like body temp or room temperature right there, but just make sure it's Kelvin right there. So for example, like 298 Kelvin is body temp, is room temp, and usually 310 is what we call body temp right there. But your numbers in there. K, the equilibrium constant, has no units. Capital K is formally unitless. How to rearrange this to isolate for terms. To solve for T, I just want to get T by itself. And to solve for K. Big things I want to kind of pay attention to are the negative sign and the natural log. Those are going to be the funniest thing for you. To solve this for T here, G like that's simply how this is set up here for T. If you're given the G value, you're given R, and you're given K, you plug in what you know there and set them all up right there. Being careful of the negative value and making sure you do the natural log of the K value, not just plugging in a number there. So those are the things I would kind of bring my attention to. Solving for K. I'm gonna have to kind of do this algebra in 2 steps. So I haven't isolated K yet, but I have just gotten R and T and G on the same side of the equation. Note that negative sign got hitched for the ride and it's out here. This does not quite solve for K. This solves for the natural log of K. So we need to do the natural log is a log to the base power of E. So the inverse of this is taking stuff to the power of E. So this whole thing here now becomes a superscript, and these, when you take this number to the natural log, cancels out. So you have E, which is your Euler's number, it's not a special number, to the power of G minus RT, making sure you keep that negative value in it. This is what equals K. Things to kind of keep in mind are just that inverse algebra there, but also this negative value here. If you have a negative value for G, this whole thing is going to become positively valued. I hope this helps. Thank you.